Among all the bizarre questions humans have asked, this one is truly thought-provoking. Are there any creatures on Earth capable of surviving in outer space? It seems like a question born of fantasy, honestly, a daydream for a quiet afternoon. Yet, when we consider the sheer tenacity of life on our own planet, the question takes on a more serious, a more profound character. We look to the stars and wonder, but perhaps the most alien forms of resilience are right here, among us, hidden in plain sight. The cosmos is the ultimate hostile environment. It is a vast, silent emptiness where, as far as we know, no life has ever originated. There's no air to breathe, no atmospheric pressure to hold a body together. Instead, there's the crushing vacuum, a constant bombardment of unfiltered solar and cosmic radiation, and temperature swings so violent they can freeze or boil an organism in an instant. It's a realm of absolute extremes, a place fundamentally at odds with the delicate, water-based chemistry that defines every living thing we have ever known. And yet, life is stubborn. It is ingenious. Today's video will dive into real animals that can survive, or potentially survive, in outer space. This is not fiction, it's science. And what you're about to learn may leave you in awe. We will journey from the microscopic to the majestic, exploring the extraordinary adaptations that push the very boundaries of what we believe is possible for life to endure, not just on Earth, but perhaps beyond it. Our journey begins not with a roar, but with a creature so small it is almost invisible. In the damp mosses and transient puddles of our world lives an animal of almost unbelievable resilience. It is the tardigrade, often affectionately known as the water bear or moss piglet. Under the microscope it appears almost comical, a tiny, eight-legged being lumbering through its miniature world. But do not be deceived by its humble appearance. This microscopic invertebrate is to date the undisputed champion of survival and the only animal confirmed to have endured the raw, unfiltered vacuum of space. The tardigrade's secret lies in an extraordinary state of suspended animation called cryptobiosis. When faced with lethal conditions, be it the desiccation of its home, freezing temperatures, or even boiling water, it curls into a desiccated, lifeless-looking ball called a ton. In this state, its metabolism slows to less than 1/100% of its normal rate. It expels nearly all the water from its body, replacing it with protective sugars and proteins that encase its cellular structures in a glass-like matrix, shielding them from harm. This state of suspended life is so profound that tardigrades have been revived after decades of being frozen solid. But their abilities go even further. Their DNA is guarded by a unique protein, aptly named DSUP, for damage suppressor. This protein acts like a physical shield, wrapping itself around the genetic code to protect it from being shattered by radiation, a threat that is constant and deadly in outer space. It is a biological innovation of breathtaking elegance, a natural defense against cosmic forces. In 2007, science put the tardigrade to the ultimate test. As part of the Photon M3 mission, thousands of these tiny creatures were sent into low Earth orbit. They were exposed directly to the void. For 10 days they faced the full, lethal cocktail of space, the hard vacuum, the unfiltered solar UV radiation, and the cosmic rays. No other animal had ever been subjected to such a trial without the protection of a spacecraft. The conditions were designed to be utterly unsurvivable. Upon their return to Earth, scientists rehydrated the tons, and something miraculous happened. They began to stir. Not only had many survived the vacuum and the cosmic rays, but some even endured the intense UV radiation and went on to reproduce successfully. They had looked into the abyss and returned, proving that life, in its most compact and determined form, could indeed persist in the most hostile environment we have ever known. The tardigrade is not just tough, it is a living testament to the sheer, stubborn power of life itself. From the microscopic, we now turn to a creature of myth and legend, an insect that has scuttled through the darker corners of human civilization for millennia, the cockroach. Its reputation for indestructibility is legendary, whispered in tales of it being the sole survivor of a nuclear apocalypse. This reputation is not entirely baseless. The cockroach is indeed a master of survival, a product of over 300 million years of evolutionary refinement that has allowed it to thrive in refuse, decay, and the forgotten spaces of our own homes. Their resilience is most famously demonstrated in their resistance to radiation. A human can withstand a dose of around 500 rads before it becomes lethal. The common cockroach, however, can endure doses many times higher, perhaps up to 6,400 rads. This isn't because of some supernatural shield, but rather a consequence of their biology. Their cells divide much more slowly than ours, typically only once a week as they molt. Since radiation is most damaging to rapidly dividing cells, the cockroach's slow cell cycle grants it a significant, if accidental, degree of protection. Furthermore, they are opportunistic survivors. They can go a month without food, hold their breath for over 40 minutes to conserve water, and even survive for a week without a head, finally succumbing not to the injury, but to dehydration. They are equipped with sensory bristles that detect the slightest puff of air, allowing them to evade a predator's strike with astonishing speed. They are, in every sense, built to last in the challenging environments of Earth. But here, the legend meets the harsh reality of physics. Could this terrestrial survivor conquer space? The answer, unequivocally, is no. Despite its radiation tolerance, the cockroach is fundamentally a creature of Earth's atmosphere. The absolute vacuum of space would be its instant undoing. Without external pressure, the liquids in its body would boil away in a process called ebulism. Its cells would rupture, and its life would be extinguished in moments. The absence of oxygen would be equally fatal. While it can hold its breath for an impressive duration, this is a temporary measure designed for earthly challenges, like being submerged in water. In the perpetual nothingness of space, there is no next breath to take. The cockroach, for all its grit and tenacity, remains bound by the same fundamental need for air and pressure that governs most life on our world. It is a survivor, but its battlefield is here, on Earth. We now lift our gaze from the ground to the skies to a bird that has perfected the art of thriving on what would kill almost any other creature, the vulture. These magnificent birds are nature's ultimate sanitation crew, soaring on thermal updrafts as they scan the landscape for the fallen. Their role in the ecosystem is vital, preventing the spread of disease by disposing of carcasses with remarkable efficiency. Their survival is not a matter of withstanding external forces, but of mastering their internal environment. A vulture's digestive system is a fortress. It possesses stomach acid with a pH close to 1, as corrosive as battery acid. This allows it to dissolve bone and, more importantly, to utterly neutralize the deadly pathogens that thrive in decaying flesh. Bacteria that cause botulism, anthrax, and cholera, microbes that would be fatal to most other animals, are destroyed in the fiery cauldron of the vulture's gut. This is a superpower forged in the crucible of rot and decay. Their immune system is equally formidable. Even if pathogens were to somehow survive the acid bath and enter the bloodstream, the vulture's immune response is incredibly robust, capable of identifying and eliminating threats that would overwhelm other species. They can feast on a carcass riddled with disease and fly away completely unharmed, a testament to an internal biology that has evolved to turn death into life. They are masters of a toxic world. But could this internal fortitude translate to survival beyond our atmosphere? The vulture, for all its biological armor, is a creature of the air. Its entire existence is defined by its ability to ride the currents of Earth's atmosphere. Its large wings are designed to catch rising columns of warm air, allowing it to soar for hours with minimal effort. In the airless void of space, these magnificent wings would be useless, unable to generate any lift. And like the cockroach, the vulture is an obligate aerobe. It breathes. Its powerful heart pumps oxygen-rich blood to the muscles that power its flight. The lack of air and pressure in space would be just as instantly fatal to a vulture as to any other bird, fish, or mammal. Its mastery is over the biological hazards of Earth, not the physical absolutes of the cosmos. Its kingdom is the sky, but a sky with wind, with pressure, and with the precious gift of oxygen. We now plunge from the heights of the sky into the crushing, eternal darkness of the deep ocean. Here, in the frigid waters of the North Atlantic, lives a creature that seems to exist outside of time itself, the Greenland shark. This is an animal that measures its life not in years or decades but in centuries. Growing at a glacial pace of less than a centimeter a year, these sharks can live for over 400 years, making them the longest living vertebrate on the planet. To survive in the deep, they are masters of endurance. They move with a slow, deliberate grace, conserving every ounce of energy in their cold, dark world. Their flesh is infused with compounds that act as a natural antifreeze, preventing ice crystals from forming in their cells. They navigate the darkness with a keen sense of smell, hunting for sleeping seals, or the carcasses that drift down from the world of light above. Their existence is a slow, patient vigil in an environment of immense pressure and perpetual cold. The Greenland shark is a living time capsule. An individual swimming today may have been born before the Industrial Revolution, before the founding of the United States. It has silently endured through ages of human history, a quiet witness swimming in the abyss. This profound longevity and adaptation to an extreme high-pressure environment might lead one to wonder about its potential for survival elsewhere. Could this ancient mariner navigate the dark ocean of space? However, its adaptations are precisely tuned to its specific environment: high pressure and cold water. The vacuum of space is the antithesis of the crushing depths it calls home. While it thrives under pressure that would flatten a human, it would meet the same fate as other complex life in a vacuum: the boiling of its internal fluids and the catastrophic failure of its biological systems. It is built for pressure, not the lack of it. Most critically, the Greenland shark, like all fish, extracts oxygen from the water using its gills. This is a delicate and efficient process, but one that is entirely dependent on the presence of H2O. In the waterless expanse of space, its gills would be useless. This ancient creature, a master of deep-sea survival and a symbol of incredible longevity, remains inextricably tied to the cold, oxygenated waters of its earthly home. Its endurance is vast, but it is an endurance defined by the ocean. From the deep sea we travel to the harshest continent on Earth, a vast desert of ice and wind, Antarctica. Here, in the face of unimaginable cold and months of darkness, thrives a symbol of endurance and community: the emperor penguin. To survive here is to master the art of withstanding cold. These remarkable birds can endure temperatures plummeting below -40 degrees Celsius and winds that howl at over 140 kilometers per hour. Their survival is a triumph of both anatomy and behavior. They are insulated by a dense layer of feathers and a thick coat of blubber. A specialized circulatory system in their feet and flippers prevents heat loss to the ice. But their most famous strategy is a social one. During the brutal Antarctic winter, the males who incubate the eggs huddle together in a tightly packed mass. This collective group, numbering in the thousands, shares body heat, with individuals constantly rotating from the cold outer edge to the warm interior. This huddle is a marvel of cooperative survival, a living, breathing city that generates its own warmth against the planet's most extreme cold. The penguins have mastered an environment that, in its own way, is as alien and hostile as any other on Earth. They raise their young in a world of ice, demonstrating a level of resilience that is nothing short of heroic. They don't just survive the cold, they conquer it through unity. Given their mastery over such an extreme environment, could they perhaps handle the cold of space? The temperatures in the shadow of a spacecraft can plummet to levels far colder than anything on Earth, reaching -150 degrees Celsius. While the penguins are masters of the cold, this is a degree of coldness that would overwhelm their biological defenses. Their feathers and blubber are designed to insulate against heat loss to air or water, not the absolute cold of a vacuum where heat radiates away instantly. Furthermore, their huddle strategy relies on the presence of an atmosphere to trap and share heat. In space, there is no medium to conduct this warmth, and of course the ever-present obstacles of vacuum and lack of oxygen remain. The emperor penguin is a master of its domain, a creature that embodies the power of adaptation and social cooperation. But its kingdom is the ice of Antarctica, not the frozen, empty void between worlds. Beyond the animals we know and recognize, the world is teeming with other, often microscopic organisms whose survival skills push the boundaries of life even further. These are not creatures of folklore or popular imagination, but they are of immense interest to scientists studying astrobiology, the potential for life beyond Earth. One of the most extraordinary is a bacterium called Deinococcus radiodurans. Listed in the Guinness Book of World Records as the world's toughest bacterium, its name hints at its superpower. It can withstand radiation doses thousands of times greater than humans. Its secret lies not in preventing DNA damage, but in repairing it with breathtaking speed and efficiency. When radiation shatters its genome into hundreds of fragments, a complex suite of enzymes goes to work, stitching the pieces back together perfectly within hours. This incredible repair mechanism has led scientists to expose it to the outside of the International Space Station, where it survived for 3 years, shielded only from UV light. It is a powerful example of life's ability to cope with one of space's greatest dangers. Then there are creatures like the braconid wasp. This parasitoid insect has a unique relationship with viruses. It injects its eggs into a host caterpillar along with a special virus that deactivates the caterpillar's immune system, allowing the wasp larvae to grow unimpeded. The virus itself shows incredible resilience, and scientists speculate that this, combined with the insect's ability to enter a dormant state, could give it a fighting chance against some of the challenges of space, at least for short durations. We have also sent more familiar organisms, like the fruit fly, Drosophila melanogaster, into orbit. These have been instrumental in studying the effects of microgravity and radiation on complex biological systems, from genetics to circadian rhythms. While they cannot survive direct exposure to space, their use inside spacecraft has taught us invaluable lessons about how life adapts to an environment so different from the one in which it evolved. These organisms, the super-repairing bacterium, the virus-wielding wasp, the common fruit fly, may not be as charismatic as a penguin or a shark, but they are crucial pioneers in our quest to understand life's limits. Each one holds a piece of the puzzle, revealing the diverse and often bizarre strategies life has developed to survive. They remind us that the most profound secrets of survival may be hidden in the smallest packages, and that the potential for life here and elsewhere may be far greater than we have ever dared to imagine. Life on Earth isn't just strong, it's astonishingly adaptive. The animals we explored today, from the indomitable tardigrade to the deep-sea shark, remind us that wherever conditions allow, life will find a way. They push, they endure, and they innovate in ways that defy our expectations. The tardigrade proved that a complex animal could, for a time, withstand the absolute hostility of the void. The others, while bound to our planet, show us the incredible spectrum of survival strategies that have flourished here. These creatures challenge our perspective. They force us to reconsider what habitable might mean not just on Earth, but across the cosmos. The universe is vast and seemingly empty, but our own world teaches us that life is relentless. It colonizes the deepest trenches, the highest mountains, and the most toxic environments. This journey through Earth's toughest survivors is more than a catalog of curiosities. It is a lesson in hope and a testament to the profound, unyielding power of biology. So what do you think? Which of these creatures impressed you the most? Was it the microscopic water bear, the true space survivor, or the ancient Greenland shark, a master of time? Drop your thoughts in the comments like this video, and don't forget to subscribe for more wild, wondrous content from the frontiers of nature and science. The more we learn about life here, the better prepared we are to recognize it, in whatever form it might take elsewhere.